we're going to go back to the trees problem we did a couple of weeks ago, and Elliot's going to explain what it is.
We had to work out the number of old trees to new trees and estimate how many there were without actually counting all of the trees on the graph.
Brilliant. What else do we know about the problem?
Oh, the circles are old trees and the triangles are new trees.
Excellent, that's what we're missing. The circles are old trees and the triangles are new trees. What I'd like you to do to start off with today is get yourself a whiteboard and a pen. I'd like you to have a look, first of all, remember what it was that you did last time we looked at this problem. Read through your work, remember your method, work out what it was that you did. Then I'd like you to try and answer some of the questions that I posed at the bottom of the paper. 5-10 minutes, off you go.
Well, we were given comments on our work and we had to think about the comments and almost give a bit of feedback to our feedback and think about ways we could use these comments to improve our work.
I got stuff like, is this the only method? And this made me think more out of the box, like, can I look at anything else and get a more accurate answer?
It said, does your method description make sense? And because I haven't seen this actual, what I wrote for a while, I looked at it and to me it didn't make as much sense. So I looked at it and interpreted it again and learned how to improve it so that someone who hadn't seen it before could read it and understand it all.
And I got how reliable are your answers?
Yeah,
so I thought of ways that you could make it more accurate, ways you could improve things, use different methods to make it more accurate.
I think it definitely helped them revisiting, because I gave them that 5 minutes at the beginning. I asked them to read through what they'd done and try and understand it. I think that helped them a lot in terms of making sure that they understood the problem properly. Normally when they see work that they've already done, they expect that to be it, and you just look at it and say, all right, I got an A or I got an 8. But this time they actually had to think about what they'd done last time and actually, first of all, remember what they did and then work out how they could improve it.
Because you were writing it down and almost answering the questions and backing your ideas up, you're almost starting to think of ways you could improve it better and stuff.
Yeah, I agree. I think it makes you think about what you've put more instead of just seeing a comment like, well done, keep it up, things like that. You have to actually think about what you've done and find ways to improve it.
What's going to happen next is you're going to work now in pairs to try and make a solution which is better than both of your solutions. And then I want you to try and make me a poster with your answer on it, with your solution to Tom's problem.
I counted all the young trees on that side and on that side, then added them together, and then did the same to that side and that side, then I times it. But then what I should have done is take away the blank spaces from each one, because those are missing trees. Yeah.
There's 1,482 trees.
Yeah.
Well, it's not the number of spaces,
because it's got empty spaces there.
You have to times that by how many trees there are in the row. So in the row there's 39, yeah. So
slowly, as I start thinking and start finding more answers, I start to become more logical.
Once you hit your logical stream, you realise that it is actually possible to do.
I think they found it quite difficult to go back and start again because they'd gone down one route of thinking, which I think is a good thing about the task, was to go back and think, well, actually, that's not worked. I need to find a new way to approach it and I need to start again and think about it again. What have you done here then, Connor?
I've added the spaces up in the trees on the left column and the spaces and trees up on the top row. Times them together, which gave me 2,500. Chose 3 rows and added the spaces up on them, times them together and worked out the average, which was 714. Then I took 2,500, take away 714, which gave me 1,786.
So what's the 714 tell you?
Tells me how many spaces there is in between.
Comparing your method to Connor's method, which one do you think is more accurate?
Well, I think they both are because we got similar. Like if you added them together, which is my total trees, it's like really close to what he got. See, with us, I had an answer and I felt confident with it, but then when I saw someone else's interpretation of the question, it made me think about it more and think about how you could get a more accurate answer, because he brought in things like ratio and averages and stuff that I hadn't thought about, so it helped me think about the problem in a different way.
So
both of them. So we thought they were both quite accurate.
Which one do you think will give you a better estimate of the old trees and young trees? So I was asking like the kids to explain to me what they'd done or looking at the posters or whatever, and so some of them they'd just explain to me what I'd done and then I'd walk away because like it's obvious that they were on top of the task and they had a good understanding and whatever, so they weren't requiring quite so much support.
1,226.75.
Oh, yeah, nice. So on that one, whatever ratio we use, we're still going to be around within 50 of the. Apart from that, that's quite a big.
That's not much.
That's quite a lot.
What's the difference? I started really basically just counting the old trees in one column and then the old trees in the row and multiplying them. But I didn't do anything about averages, and I was wondering why I was getting such low amounts of trees. So we started to look at averages and ratio and percentages, and we put it into fractions which found our ratio and then gave us large averages. And we managed in the end, after averaging the old trees and the new trees, like adding them together to find the whole amount of trees, and we all could got the answers about the amount of young trees and the amount of old trees averaged.
Some of them chose to do averages, and there was a lot of proportional representation in there because obviously you've got to find one row and multiply by 50. That's the most sort of basic answer. Some of them decided to use percentages, there was fractions, and I had a couple who did ratios as well. What I'd like to do now is I'd just like to get you lot talking about what you've done. On Elliot and Becky, can I have your poster please? Sorry. I'd like Elliot and Becky just to explain what it is that they've done.
Worked out the amount of old trees on the first row and the new trees on the first row, and it was roughly a ratio of 3 to 1. So then we did 1,521 divided by 4 and worked out that old trees were about 1,140 overall and new trees 380.
Okay. Any thoughts? Liam's itching to put his hand up. Go on, Liam, what do you want to say?
Yeah, we've kind of done the same thing, but we've got a slightly different answer. We've kind of like worked out the ratio of new to old trees and then divided it by how many total trees we think there are by just counting a row and a column instead of counting them all.
So, how many trees did you think there were, and how did you do that, sorry?
Well, we counted the number of trees in a row,
right,
all together, not new and old,
okay,
and then the number of trees in a column, and we got 1,482, which is slightly different to theirs.
Oh right, so you've used the same method to find the total number.
And then
of
put
trees.
it in a ratio.
Oh, well, that's quite interesting, isn't it? Because they both used the same method to find the total number of trees, and they've got answers which are about 50 apart. So why might that be? Why is it that even though they've used exactly the same method to work out how many trees there are, they've got a different answer?
They've miscounted.
They might have miscounted. That's true.
Slightly different estimations.
How do you mean?
Like when they're counting them and stuff, like the way you counted one row and one column and times them together to find out how many there are all together. There are some gaps in some of the rows and columns, so.
Yeah, they could have done that.
Well, Elliot and that said they like roughly worked it out at 3 to 1. Liam might have a different ratio that's more accurate.
So what was your ratio then, Liam?
2.5 to 1.
2.5 to 1?
Yeah, because what we did is we counted that there's 28 old trees in a row.
Yeah.
And 27 old trees in a column. So kind of like went half and half and put it in a top-heavy fraction. So we had like 27 over 11, because that's the number of new trees on both the column and the row. And then we put that as a ratio, which is 2.5 to 1, and then we divided the total number of trees by 3.5, and then put it in.
Okay, so their ratios are slightly different, so that's going to end up with different answers in total. Have a go again, going back to your methods. Think about what we've just talked about, but have a go See if there's anything you'd like to change about your method, see if there's anything you'd like to improve. Make sure that you can understand it, and you've got about 10 minutes to have another go. The biggest difference that I noticed in between their work individually and their work together after today, and I don't know whether that's because they were working as a pair or my comments, but their justifications were a lot better. They seemed to be a lot more confident about writing stuff down. I had one girl whose first attempt, she counted the first 5 rows and then averaged that out and then multiplied by 50 to work out the whole thing. And I asked her how much she cross-referenced her results, because she's got a really good method and she's explained it really well. So I asked her how much you cross-reference your results to sort of double-check it. And her final thing, she's looked at that, and I don't know what she did, whether that was her partner's suggestion or whatever, but she's got the same thing as she did on her testing, and then to check whether her results were accurate or not, she's then counted columns. So she took the first 5 columns and averaged those out. So she did rows and columns to sort of cross-reference whether her things were the same, and then she averaged out the differences to come up with her final answers.